Hello everyone. In complete Python series, now in this video I am going to explain about numbers, which is one of the data type in Python. I've already mentioned about this data type in data types in Python video, but in this video we are going to know about numbers in detail. So let us start. The first thing we are going to know about is how many types of data types in numbers. Like a number can be presented in Python in form of integer, in form of floating point numbers, and in the form of complex number, right? So let us see in our presentation. Here already you can see number data types stored in numeric values. It's always stored in numeric values, and there are three built-in number types available in Python, as I have already told you. First is int, which is also known as integer. Second is floating numbers, and then complex numbers. So int is the class int. So in Python is internally for the integer there is one separate class which is the class int, and similarly for the float there is a class float. If you're storing any value of which is float value, it's created the one object from the class float and then it stores. Similarly for the complex number, there is a class complex in Python. So next we are going in detail with the integers. So as I already mentioned that integer has one class, built-in class in Python, which is known as int. And what is the integer? It's the whole number. In Python, whatever the whole number, it's a signed whole number. Maybe it will be plus or minus. All the whole numbers are integers. And in Python, there is no limit to how long you can store the integer value in a variable. So it's limitless, right? Now let us see in our VS Code how a variable can be declared as an integer. Like suppose that I am taking one variable num and I am putting some value 20 to it. So basically I am assigning 20 to num, and num, if 20 is already an integer, then Python knows that variable type of num will be integer. So if I try to print type of variable of num, right? So let it update, and if I run this program, it will print class int. You can see int. So this is the integer class, and the object is num, right? So let us not confused in class and object, but understood that integer is one data type and of number system, number data type, and it's a store whole numbers, right? And if you want to check it's a integer or not, we can check with the function type, right? And the next point is there are three ways we can form integer objects, and we can assign some values to integer object. How? One is the literal representation. You had directly assigned one numeric value, which is a whole number, to a variable. So this is an integer object, num is. Another way is any expression evaluating to an integer. Like here I have two numbers. Number one is 25 and number two is 10. And I am doing some evaluation, means expression, two numbers I'm adding up, and then it's assigning to num. So here I am creating another object of which is a numeric data type, as integer data type, by evaluating an expression. And third is I have already one floating point number or any string, which is that string has also numbers, and if I want to assign that to a integer object, we'll have to typecast. Basically I'm typecasting this floating point to integer. Similarly, this is a string and I'm typecasting with the integer. Let us see one example here how it's working. So I'm going to comment out this one so that it will not confuse with the, suppose first one already we have seen that this way I will assign the first example. Second example, I'm taking num1 equal to 20, num2 equal to 30. Then I am getting another number num equal to num1 plus num2, and then print num, right? So you see we are able to, if I am running directly, it's printing 50, right? And if you check the type of this variable is print type num, and if I run this one, you see class int. So how we have created this integer object from this expression. So one is the direct assignment, another is through the evaluating the expression, right? And basically the direct one is known as literal representation. So you can, some better word is, this is literal representation when you assign a numeric value or integer directly to a variable. Third is value can be floating point or string. So I'm just commenting this one. After commenting, suppose that I have one variable num float, right? And this will be like a 20.22, right? I have str num, and that string holding this value. If you try to find the type of num float, we'll have to print this one, print type num float, right? So if you print, let me clear the screen, sorry for typo, I'm clearing, then running. You see it's a float type, right? But if I typecast it, means I have put it here int, right? And then put it in a bracket, right? So now see what it's printing. You see now it's integer. Previously it is float, now it's integer. So I've typecasted this floating number to integer through this int function, right? Similarly, this is the string. If I print this one, print type str num, and let me comment this. So it's a string, right? But if I typecast this through the int, let me comment, okay, and now check. Now it's a int. So this is another way to convert different data type into the integer by typecasting. So this is the three ways. In these three ways, one is literal representation, another is expression evaluation, and third is using int function, right? So this is the forming integer objects. Now there are different types of numbers, you know, in there are maybe binary number, there is octal numbers, then hexadecimal number, where the internally machines understand these numbers. So like the binary number, this is a combination of only two numbers, 0 and 1, and we denote binary number through start from 0b, right? And if you check the type of this variable, whether it's written from its binary number, but if you check, Python will understood as an integer. It will transfer, it will you can say transform into the integer. You always treat as an integer. Similarly, octal numbers. What are the octal numbers? Octal numbers which is whose base value is 8, And what are the numbers we take in the octal numbers? 0, 1, 2, 3, 4, 5, 6 and 7. Only these 8 numbers are in octal presentation will we use. Hexadecimal, as you already know that the base is here is 16, and what are those numbers we consider or in hexadecimal? So you start from 0 to 9, these 10 numbers, and A, B, C, D and E. Total A, B, C, D, E, F. So till F. So total we have 16 numbers are there, right? So this is the presentation of hexagonal number. Suppose that, let us see with an example how binary number are dealt by Python. So let me comment this one. Here I'm just writing binary num equal to, here start from 0, B, 10, 10, 10. Let us check the data type. Print type, and then bin num, right? Let me clear the screen so that it's much visible. And I'm running this program. You see it printing int. The type of this bin is integer, whether it's a numeric, and if I'll try to print this value, let us see what it's printing. Print bin number, right? Bin number, right? Here it's entered into the, right? So if I'm running this program, you see it's reprinting 42 and type is int. So basically it's transformed this binary number or print function to decimal number. I'm taking one smaller number, then see, you will be better clarification on this one. It's a 3, 1, 1 in binary number, in decimal you convert, you will get 3 and type is int. Similarly, if number is octal, OCT num equal to, here is 0, O, then you can take any number, 0, not 5, it will not consider. Similarly, if you print these two values plus, I'm just commenting this one so that our presentation will be okay. Now see what is happening here. Let me clear it. It's a 3 and type is int. No, actually the variable name should be here octal number. It was taking the previous one. So yes, you see 05 octal presentation, it's a 5 and the type is int. Similarly, I'm commenting these two and taking one more variable, which is hexa, hex and num equal to 0 x A102. This is hexadecimal number, right? And if I print this one, print hex num, what you will get? Let me clear it. Not here, it should be written here. Clear it, and you will see 41218. So if you transform this number into decimal number, it will get 41218, right? And if you check the data type, print type and then hex num, right? So it will be integer. So this is way, whether it's a binary or octal number or hexadecimal number, Three are treated by Python variables as a integer class type, and when you print you will get the decimal value of those numbers, right? So now next move into what are the some use of those numbers. We can perform various type of operations on integers, like if you want to add two numbers or subtract one number from another number or add more numbers, we can perform those operations on integers, whether a division, whether a multiplication, whether a modulus, you find the remainder, and or exponent. Let us see one by one example for each one. So let us go to our VS Code. I'm just commenting these two so that you will have no confusion in understanding. So suppose that num1 is 20, num2 is 10, right? Then what is the first operation we can do? Num equal to num1 plus num2. We can do this one. This is the addition, and you can print. Already we have checked this one num, so if you see it's already adding, two numbers are added here. Similarly, what we can do, num equal to subtract one number from another, num1 minus num2, right? If you print, we are getting 10, right? Let me clear the screen and run again. You are getting 10. So minus operation you can perform. Similarly, num equal to num1 into num2. We are doing multiplication. Let us print this one. 200 we are getting. Similarly, we can do num equal to num1 divided by num2. So what we are dividing? 20 is dividing by 10, it should come 2. So let us see what is printing. We are getting 2, right? Similarly, suppose that if you want to get the remainder, so let me make it 21, and then num equal to num1, and to get the remainder modulus we will use percentage sign, and then num2, right? Let us see what we are getting. 1. If we divide 21 through 10, we will get the remainder 1. And the last one is, suppose that you want to get the some exponent like num1 and star 2, right? So what will happen? It's star 2 means I'm making is 0, 2 times multiplied 20, right? You should get 400. So let us see 400, right? Let me clear the screen, then clear visibility, right? 400. So these are the some operations we can perform with the integers. Now we are going to understand another numbers type, which is floating numbers. What is floating numbers? So a number which is a combination of a whole number, dot, and some number after the dots, and there are no limitations of how many fractional part. Basically the number from the left are the whole number, and number from the after the dot are right numbers, and those are the floating points. So in Python there is no any limitations. So let us see how we present the floating point numbers. So before going into, let us see the slide here. As I have already mentioned, a floating point number has an integer part and a fractional part separated by a decimal point symbol dot, right? A floating point number has an integer part and a fractional part separated by a decimal point dot. For example, 2.3, 9.99, these are the floating point numbers. Clear? Now, so let us see one example. Float num. I'm not able to take the float because that is the reserved word. So you can write something like 0.3. This is the floating point number, right? It's up to you how many points you want to put here, right? Now, also in Python there is no restriction on how many digits after the decimal point can a floating point number have. I already told you. E or small e symbol is used to display bigger numbers. E stands for 10 raised to that number, right? For example, E4 is 10 to the power 4, 10 raised to 4, right? Or E minus 3 is 10 raised to minus 3. For example, E10. So let us see some example here. So this is the floating. How we'll know that this is the floating number or something like that? So you know you can print type then float number. So let us see what it printing. You see class float. The type of this variable is float, right? And I'm taking another number, float num2 equal to 20 E4, right? So what it means, 20 into 10 to the power 4. So if you print this one, float num2 type, this is also a float number, right? So this is the meaning of E. Sometimes we see the numbers. Basically, these are the before the representation of bigger numbers, right? Now, let us see the next point in floating point numbers. In scientific notation, number has a coefficient and exponent part. The coefficient should be float greater than or equal to 1 but less than 10. For example, here 1.23 and 10 to the power 3. Here 9.9 10 to the power minus 5, or 1 10 to the power 10 are example of float with scientific notations. So here it's up to you. You can put here plus sign or minus sign. It's upon you, right? So these are the some presentation for the scientific. We do not write something like 20 or something. Here we only like a float num3 equal to 9 point. This value can be 1 to 9.9, right? And after that 9.9, and after that we put the E, then raise, right? So this is the presentation of scientific presentation of numbers in Python, right? Now, another is very important data type under the numbers is complex numbers data type. The class used for this data type is the complex. Here is the complex number. And if you see here the definition, a complex number consists of real part and imaginary part separated by either plus or minus. The real part can be any floating point or itself a complex number or number. The imaginary part is also a floating or complex but multiplied by a imaginary number. Here you see the one of the format of a complex number. This is the real part. It can be a floating point number. This can be also a floating point number or imaginary number. This can be also imaginary number. And this is the J, which is representing that this combination, this floating point number multiplied by J is representing that this is the imaginary number. For example, 2 plus 8J. Here floating point number, and J. This is the imaginary number. and where basically we use the complex numbers. Basically, complex numbers are used in wave functions, in physics, design filters, signal integrity in digital electronics, radio astronomy. So where and multiple Fourier analysis, many scientific calculations are done through this complex number. So we'll look into detail when we come into the implementation part. But for now, this is the understanding regarding the complex number. So let us see one example of complex number. So it will be better clear to us. I'm going to write comp underscore num, right? And I'm going to put 2 plus 4j, right? Is it a complex number? I will check. Print type comp number, right? Let me clear the screen, then it will be more visible. Let us run again. We find class complex, right? This is the format of complex number. Now also here in complex numbers, we can create a complex number through Python's function complex. How we can do that? So you can do that like a complex number equal to complex. First the real part, and this is the imaginary part. So let us create one. I'm commenting this one, not commenting, commenting this, no, comp num2. I'm taking another number, and I'm putting a complex 3.3 comma 2, right? And let us see the type of this number. Let us run. You see complex, right? So this is how, using the complex function of Python, you can generate or create complex numbers. Also, one another good method of complex number is how you can find this real number and imaginary part if you have the complex number. So we will use this real and image attributes of complex number. So let us see. We have already come to a complex number, and suppose that I want to know from this one, I want to know the real part. So I'll write real. So let us see what it's printing. You see, let me clear it and then run it. So it's typing the type, but always you see the number 3.3, no, it's 2. 2 is a floating point, because in a complex number, I'm just removing this one, it's confusing. So 2 is the floating point number, that's why the real part printed by Python is float. So you know this is the real part, and I printed type. Instead of type, I wanted to print the value. So this way you can print the value, right? So it's 2.0, right? Similarly, if you want to know the imaginary part, print comp number dot image, imag, not e, right? And now let us print. You see 4.0, here is a 4. So basically, whenever you try to find real and imaginary part, the real and imaginary part both are floating point number. This is also floating point and this is also floating. That's why it's returning 2.0 and 4.0. So this is the high level understanding of complex number, and we know that how we can present complex number and how we can create complex number through the complex function of Python. And if you have any complex number, you can extract a real part and imaginary part. So that's it in this video, and thank you for watching this video. And in the next video, I'll come with a new topic. If you yet not subscribed my channel, please subscribe and enjoy coming with lots of video. Have a nice time.